So consider this given problem statement. So it says that the tuple x naught comma y naught, this is the solution of the following equations, that is 2x to the power natural log of 2, which is equal to 3y to the power natural log of 3. Next, 3 to the power natural log of x, and that is equal to 2 to the power natural log of y. So in that case, we need to compute this particular value over here, right? Now, so I will just consider one of the equation here. So first of all, I'll consider this particular equation. Now, if you observe here, I can take natural log on both the sides. So for this one, I'll apply natural log on both sides. So on this side, I'll take natural log, and on the other side also, I'll consider natural log over here. Now, after applying the property of logarithms, this can be written as natural log of x times natural log of 3. And this one we can write here as natural log of y times natural log of 2. So from this we can clearly observe that this natural log of x divided by natural log of 2, this can be written equal to natural log of y divided by natural log of 3. And let us say this is some constant k. This is just for our assumption, right? Now consider the next one. Also, it is given that this particular equation, so if I talk about this particular equation, that is this one, right? Now I'll consider this one and try to simplify this one. Now I'll take natural log on both the side. So the same equation I'll take, and for this one I will apply natural log over here, and for the other side also I'll be applying natural log over here, right? Yes. Now I will apply the logarithmic properties. So first apply the property of log and simplify this one. So here this log 2, natural log of 2, can be written here as it is, and here we'll have natural log of 2x in the argument, right? Now in this side, similarly in this side I can write here natural log of 3, and then here instead of this natural log of 3y. Now I'll apply the property, that is product to sum. I'll apply here the concept of this product to sum. So natural log of 2 outside, and this can be written as log 2, and this one as natural log of x. And this one here natural log of 3 outside, and here natural log of 3 plus natural log of y. So this one is simplified using the log property, that is product to summation. Now on proceeding further, if I multiply this log 2, if I just multiply this quantity with the internal quantities, so this can be written as natural log 2 whole square plus this will be natural log of 2 times natural log of x. Similarly, this one can be written as natural log of natural log of 3 whole square plus natural log of 3 times natural log of y. Now from this one, here, we can write this one as, so if you observe here, this natural log of x can be written as log log 2 times k, and this natural log of y can be written as, that is log 3 times k. So I'll be replacing this, right? So let me take this equation and let me make the replacements. So instead of log x, I can write k times log 2. So instead of this one, I can write here k times natural log of 2. Similarly, for log y, I can write k times natural log of 3. So instead of this one, I can write k times natural log of 3. Now, on resolving this further, I can write this natural log of 2 whole square outside, and this can be written as 1 plus k, right? And similarly, for this one as well, I can write natural log of 3 whole square outside. So here 1, that is a common factor. This common factor goes outside, and then here we'll write 1. Again, log 3 times log 3 is log 3 whole square, and again k remains here as it is. Now, from this one, we can frame this equation, that is 1 plus k, and here I can write in the other factor, that is natural log 2 whole square minus natural log of 3 whole square, and this is equal to 0. So if you observe, this one is a non-zero quantity. So we can divide this on both the side, and from this we can get that 1 plus k is equal to 0. And this clearly implies that k will be equal to -1, right? Now, so from this entire discussion, we can say that my natural log of x is equal to -1. Why so? Because we have observed this thing, that this natural log of x is equal to k. So k is -1, and since this k is multiplied with natural log of 2, so this can be written as -1 times natural log of 2. So simply I can write natural log of 2. So from this we can say, on applying the property of log further, so this can be written as, so this -1 can be taken in the power of 2, right? So from this we can write that this will be equal to natural log of 1 by 2. So from this we can get the value of x, that is 1 by 2 by comparison. So similarly for x as well, for y as well, I can compute this value. That is, natural log of y is equal to negative natural log of 3, and this one can be written as 1/3. So natural log of y, that is equal to natural log of 1/3. Now, so from this we are getting x naught and y naught, right? So finally we can say that this is the expression that we need to resolve. This is the expression that we need to resolve. This is the given expression. Now, this x naught is nothing but this 1 by 2, because by comparison we are getting this value as 1 by 2 times, for this y naught I am getting here, that is 1/3. So I'll write here 1/3. So this becomes 1 by 6, and 1 by 6, if I take inverse of this again, I'll get 6 as the answer. So for this particular problem statement, 6 is the correct answer. So I hope the steps are easy to understand and you are able to follow this, and hence we are getting the answer as 6.